In the previous lecture on the introduction to matrices, all we did was compare matrices to see if they were equal. But you can also add and subtract the matrices, and you can do several kinds of matrix multiplication. The one to be covered here is called scalar multiplication. Since this is a fairly new topic, let's review what we know so far. A matrix is a grid of numbers. The columns are vertical. The rows are horizontal. Each element is denoted by Aij, where I is the row number and J is the column number. And here's a sample right here. Generally, if you had B for your matrix name, then you would use lowercase b for the elements. Of course, if you have actual numbers, then you would put actual numbers into the matrix. The order of the matrix is the number of rows times the number of columns. Here, there's m rows and n columns. A little hard to see m and n when you get the slide reduced enough to get on this Camtasia screen, but this is m rows and n columns, so it's an m by n matrix, row by column. And that's the order, or sometimes we say as slang, the size of the matrix. Now when you go to add matrices together, you can only add or subtract matrices if they are of the same order. That means the same number of rows and the same number of columns. So if I have a matrix, a 10 by 12 matrix, I can only add 10 by 12 matrices together to it. I can only subtract 10 by 12 matrices from it. That's because matrix addition and subtraction goes element by element. So here's an example and also an application. Let's say your matrix, which I'm going to call R, is your gross sales. This would be your revenue for a company that sells, let's say you sell 2 products, okay? And maybe you have 3 locations. The C matrix will be your cost matrix. It is the cost for those 2 products at the 3 locations for the same year. I'm going to put the revenues for the product in the rows, and I'm going to put the columns are going to be the store locations. So the revenue and the cost are going to go in the rows, and the columns are going to be the store location. So these are going to be, there's 2 products, so there's going to be 2 rows. There's 3 locations, so there'll be 3 columns. So these will be 2 by 3 matrices. All right. The profit matrix would be obtained by subtracting the costs from the revenue. See, once you have these stored in the computer or in your calculator, all you have to do is issue the command P equals R minus C, and all the arithmetic is taken care of by the computer. The big problem is entering the matrices in the first place. The second big problem is making sure you don't switch around your definitions of what's in the rows and what's in the columns. So we have 3 columns. Here's your location A, location B, and your location C, and you can sell whatever you want to sell there. I'll sell goldfish and shoes. Be a good store. Okay, so I brought in $450 selling goldfish at location A, and I brought in $401 selling shoes at location A. Get over to location C. I sold $850 worth of goldfish, and only $150 did I bring in for shoes. This is revenue. Now, when I go to make the cost matrix, it better have exactly the same definitions, otherwise your calculations will make no sense. And like I said, when you make this matrix, you lose all this descriptive information, so you have to be careful, especially if someone else starts making the matrices for you. So again, we better have location A, B, and C lined up with these columns, and we'll have, this is the cost for procuring these goldfish and shoes. I think I want to go to the store. Be a good store. Okay, now the profit is revenue minus cost. So here's how you subtract. You subtract the entry in row 1, column 1. Well, I'm going the other way. You select this entry, row 1, column 1, from this entry, row 1, column 1, and that's where I get my new row 1, column 1. It's going to be 450 minus 375. When I get done with the profit, here's locations A, B, and C. Again, we have goldfish and shoes. Okay. This means my profit at location A from my sale of goldfish was $75. Now let's look how shoes did. I will take the cost for the shoes at location A, which is $410, and subtract that from the revenue for shoes at location A. That gives me this number right here. You see I'm maintaining the same structure. Alright, minus 10. That means I lost $10 on my shoe sales. And then we can continue through the rest. Let's look at C. Here I would take C. This would be the cost for the goldfish at location C, and I subtract it from my revenue for selling goldfish at location C, end up with $140. As far as the shoes go, $200 in cost for the shoes at location C, only $150 in revenue. I lost $50 on my shoe sales in location C. And that's how you subtract, element by element, and that's why the matrices have to have exactly the same order. Now we'll look at scalar multiplication. With matrices, there's many different kinds of multiplication. There's matrix multiplication, scalar multiplication. When you get into vectors, you have dot products and cross products. So there's many different ways to combine, under multiplication, to combine matrices. This is called scalar multiplication. This arrangement here, consisting of all these elements, is the matrix, or if it has only one column or one row, we call it vector. Right. Each element is a scalar. Those are the numbers that you use to fill up your grid. They're the numbers. For the most part, they're real numbers. A problem like business, they would be real numbers. If you're doing a more complicated problem in physics, they might be complex numbers. But whatever kind of numbers you are that you're using to fill up your matrix, those are your scalars. You can multiply the matrix by a scalar. Here, 5 is just a number. And I can multiply the matrix by 5. And how scalar multiplication works is that scalar multiplies every single element in the matrix. It distributes to every element, not just the first one, not just the first row, not just the first column, but every single element. And that's scalar multiplication. And the scalar multiplication is very handy for business. Let's say you have here's the some materials that you order. This is the amount that you order. 3 kinds of materials, 2 different manufacturing locations. So this is manufacturing location A and B, let's say, and I don't know what you're making, cupboards and tables and something else. I guess maybe you make, well, chairs. Not very imaginative here. Okay. 3 different products at 2 locations, and I've put together a matrix of the amount that I have to order. Okay, so much supplies for the cupboards, so much for tables, so much for chairs at location A, and I have similar amounts that I order for location B. Now let's say your entire order, all the materials at all locations, has to be increased by 20%. Okay, that means that you would have 1.2 times as much material at every location that you would have to order, and you would like your new amount matrix, the new matrix of the amounts that you have to order. In order to compute this, all you need to do is multiply 1.20 times A. If you want the amount of increase, you would go 0.2 times A. That's the amount of increase, but if you want the new amounts that you have to order, you have to include, of course, your base amount. So you would multiply by 1.2 times A. You see how this distributes to every single thing, and that will increase every one of your amounts by 20%. So this kind of multiplication only works when everything goes up by the same amount or down by the same amount. So here's a little bit of summary of these rules. The order of the matrix, oh, I need a pen. The order of the matrix is important in matrix addition and subtraction. You have to have the same order. If your first matrix is 10 by 6, then you can only add to it matrices that are 10 by 6, or subtract matrices from it that are 10 by 6. And then it goes element by element. In fact, both of these are element by element. Okay? When you get to scalar multiplication, it doesn't matter about the order. You're multiplying the matrix, let's say A, by some number. I'll call it alpha. This is a scalar. It's just a plain old number. It's not another matrix. And the scalar multiplies every element. It multiplies every element in the matrix. The scalar, that's a term that denotes the numbers that you use to fill up your matrix.